In this lesson, I'd like us to develop the idea of the reduction formulae. We know, for instance, that an angle, say 210 degrees, is not acute. So this is not acute, but 210 degrees can be written somehow in terms of an acute angle. For instance, we can write 210 as 180 plus 30 degrees. You see, we're now introducing the 30 degrees, which is actually an acute angle. Similarly, 300 degrees is not acute, but we can write 300 degrees in such a way that we actually make use of an acute angle. So we can write this, for instance, as 360 subtract 60 degrees. So 60 is acute, so 300 can be written as 360 minus 60. Let's look at another one. 150 degrees is not acute, it is obtuse. But how can we write 150 so that there is an element of an acute angle? This we can write as 180 degrees subtract 30. That will give us 150 degrees. Right. I think these will be fine for now as examples. And so the form that we want, I'm interested in 180 degrees and 360 degrees for now. You will notice here I've got, I said 180 plus 30, I said 360 minus 60, I said 180 minus 30. I can actually add one more. Take, for instance, 370, so 370 degrees. So 370 degrees can be written as 360 plus 10. So I want us to use 180 degrees for now and 360 degrees. So we are saying we can rewrite some of these angles in the form 180 degrees plus or minus some acute angle, right? And we can also write some of these angles as 360 degrees plus or minus some acute angle. And this is what we mean when we talk about the reduction formulae. We are reducing from those non-acute angles into a format that actually includes the acute angle. I'll show you this in the context of the cast diagram. In this diagram, we have 0 degrees there. We have 90 degrees there. 180 degrees here. 270 degrees there. Then we go back there to 360 degrees. I want us to assume that this angle in the first quadrant is equal to theta. Now those red lines there are straight lines. So you will notice then that using symmetry and some properties of angles, this here will also be theta, that's vertically opposite to that. So this is theta, so this also here, from there to there, make that one theta. And from here to there also, make that one equal to theta. But the most important thing is we've got in the first quadrant our angle theta. So theta is some acute angle in the first quadrant. Now the thing is, if I measure from 0 degrees up to here, that angle there is in the second quadrant, and clearly that angle there is not theta. But I want to write that angle in terms of theta. Do you see what theta will be? I mean, what my angle will be? That should be 180 degrees subtract theta. Okay. Now look at this. Now let's measure from here, from 0 degrees, all the way to the third quadrant there. That orange angle there. How many degrees is that? Right, did you say 180 plus theta? Okay. And now for the angle in the fourth quadrant, I know you can measure like this, start from 0, measure all the way like that. And that will obviously be something else. I don't want to measure it that way. I just want us to start from 0 and move this time in an anti-clockwise direction. So obviously this angle here will be, you could call it negative theta, that's fine, because you're measuring from 0 in a clockwise direction, so that is negative theta, but we will come to negative theta later on. But just take this in this context. We're starting from 0 degrees, and we're going all the way up to here. You will agree that the remaining angle, which is this angle here, is actually 360 degrees subtract theta. Let me draw that diagram again without these many lines. I want you to see what I'm talking about. So what we are saying in summary is, in quadrant 1, we do get our angle theta, where theta is acute. So theta is acute, so we get our angle theta. But in quadrant 2, if theta is acute, then theta is in the first quadrant. So in quadrant 2, we actually would get 180 minus theta. Then in quadrant 3, we get 180 plus theta. And in quadrant 4, we get 360 degrees minus theta. And back again to quadrant 1, we get 360 degrees plus theta. What this means is, if you are given an angle in these quadrants, you can actually rewrite that angle in the form of these reductions that we have here. For instance, if you have an angle like 150, there's 150, we know that 150 degrees will be in the second quadrant. So 150 can be rewritten as 180 minus 30. Okay, so instead of 150, we can write 180 minus 30. If, for instance, we have an angle like 210, 210 is in the third quadrant. So we can write 210 as 180 plus 30 degrees. Now 30 degrees is acute, and it's in the first quadrant. If you have, for instance, an angle, say 330 degrees. So 330 degrees we know is between 270 and 360 degrees in the fourth quadrant. So 330 should be written as 360 subtract, so it's 360 subtract 30 degrees. If you do have an angle like 370, for instance, then 370 can be written as 360 plus 10. Right, we will be making use of this. And what we are saying is we should be able to work out the sine of angle theta. Remember, theta is in the first quadrant. The sine of theta, the cosine of theta. Let me fix that. The cosine of theta. So the cosine of theta, then the tangent of theta. But in the first quadrant, we also have 360 plus theta. Remember, theta is here as well as 360 plus theta. So we should be able to work out the sine of 360 plus theta and work out the cosine of 360 plus theta and also work out the tangent of 360 plus theta. Now here's something interesting. It's interesting to know that the sine of 360 plus theta is actually the same as the sine of theta, and the cosine of 360 plus theta is the same as the cosine of theta. Tangent of 360 plus theta is the same as tan of theta. You will need to learn that. That is never going to be provided in your formula booklet. So we need to start learning this one now. In this second quadrant, we said we have 180 minus theta. So we should be able to work out sine of 180 degrees minus theta, work out cosine of 180 minus theta, and work out the tangent of 180 minus theta. Now, we know that in the second quadrant, only sine is positive. So sine is positive, and the good news, the sine of 180 minus theta is actually the same as the sine of theta. And the cosine, now cosine in the second quadrant is negative, so it's negative cosine of theta. So cosine of 180 minus theta will give you minus cosine theta. Then tangent of 180 minus theta. Now tangent in the second quadrant is negative, so it's a minus, but it's a minus tan of theta. And so now very quickly, in the third quadrant, we have 180 plus theta. And we want to work out the sine of 180 plus theta, then the cosine of 180 plus theta, and the tangent of 180 plus theta. Now in this quadrant, only tangent is positive, the rest are negative. So sine of 180 plus theta will give you minus sine theta. Cosine will be minus cosine theta. Tangent will be positive because tangent is positive here. So the tangent of 180 plus theta is the same as the tangent of theta. These are called your reduction formulae. Now in the fourth quadrant, we have 360 minus theta. So we shall be talking about the sine of 360 minus theta and the cosine of 360 minus theta and the tangent of 360 minus theta. Now in this quadrant, only cosine. In this quadrant, only cosine is positive. The rest are negative. So sine 360 minus theta will give you negative, and it's negative sine of theta. Cosine is positive in the fourth quadrant, so the cosine of that 360 minus theta there, that big angle, 360 minus theta is just the same as the cosine of theta. The tangent of 360 minus theta, tan is negative here, so that will be minus tan of theta. So class, these are your reduction formulae. Let's start with learning these for this lesson. Something to do with 180 plus or minus theta, and then something to do with 360 plus or minus theta. And we are reducing angles from obtuse or non-acute, and we're writing them in terms of an acute angle.